All right, welcome to the Explainer. Today, we're diving deep into the single most important part of your computer, what's basically the brain of the whole operation, the central processing unit, or, the CPU. It's the question we all have when we're shopping for a new laptop or PC. You see two machines, they look pretty much the same, but one costs way more and promises to be ridiculously fast. So what's the deal? Well, the answer almost always comes down to what's inside this tiny, incredible chip. But the second you look at the specs, you get hit with this wall of jargon, right? Gigahertz, cores, threads. What does any of that actually mean? Don't worry, today we're going to break it all down. And we're going to start by making things a little more, well, delicious. So to make this all super easy to wrap your head around, we're going to use one simple analogy for this whole explainer. I want you to think of your computer's CPU as a high-end professional kitchen. Its job is to take your requests, which are like recipes or, your programs, and cook them up perfectly. All right, so the first thing we need to understand about our kitchen is how good the staff is. And that all starts with the speed of our head chef. And that brings us to clock speed, which is measured in gigahertz or GHz. Just picture a metronome in our kitchen, ticking away. With every single tick, our chef does one basic thing, like picking up a knife or making one slice of an onion. Clock speed is just how fast that metronome is ticking. And just how fast are we talking here? Well, a CPU with a 4 gigahertz clock speed means that metronome is ticking 4 times billion times every single second. That is an insane number of tiny actions our chef can perform, from one moment to the next. Okay, so you're probably thinking, great, higher number, better computer, right? Well, not so fast. Speed is only part of the story. Think about it, a newer, more modern chef, what we call a newer CPU architecture, is just plain smarter. They might be able to chop the entire onion with a single tick of the metronome, while an older chef might need a few ticks to get it done. So a fast but clumsy chef doesn't always win the race. So having one super fast chef is great. But what happens when the dinner rush hits and tons of orders come flying into the kitchen all at once? No matter how fast that one chef is, one person can only do so much. This is where the kitchen needs to staff up. And that brings us to cores. A core is, quite simply, a full chef in our kitchen. In the old days, a CPU only had one core. One poor chef trying to juggle every single order, one after another. Talk about stressful. But a modern quad-core CPU? That's like having 4 separate chefs in your kitchen. This is real multitasking. Each chef can be working on a totally different recipe or a different program at the exact same time. Now, let's get even more detailed and talk about threads. If a core is a chef, then you can think of a thread as one of that chef's hands. Now, a standard chef can use one hand for one task, but some CPUs have a special skill, a technology like Intel's hyperthreading, that basically makes the chefs ambidextrous. This lets one chef, one physical core, use both hands to work on 2 tasks at once. It's like having a virtual partner, making the whole kitchen run that much smoother. So, let's put it all together. When you see a computer advertised with a 4-core, 8-thread CPU, what that means in our kitchen is you've got 4 highly skilled chefs, and each one of them is so good they can juggle 2 separate tasks or threads at the same time. It's an amazing setup for programs that need to do a lot of things at once. All right, we know how the kitchen works now, so let's talk about the 2 giant competing restaurant empires that pretty much own the whole block, Intel and AMD. For the longest time, Intel was the king of the hill, no question. Their whole philosophy was to build kitchens with fewer but exceptionally fast chefs. This made them amazing at cooking up a single, really complex dish super quickly, which is why they were the go-to for things like gaming, which loves that raw single-chef speed. But then AMD mounted this incredible comeback, and their strategy? Totally different. For a similar price, they decided to give you more chefs. They packed in more cores and more threads, making their kitchens absolute powerhouses for cooking many different dishes all at once. Perfect for stuff like heavy-duty video editing. Today, that rivalry is just fierce. It's forced Intel to add more chefs to its kitchens, and it's pushed AMD to make its individual chefs way, way faster. And the result of all this fighting? It's just fantastic for us, the people actually buying the stuff, because it drives innovation and gives us way better performance for our money. Okay, so that's all the theory. But what does this actually mean for you? We've got all this knowledge. Now for the payoff. How do you actually use it to pick the right CPU? Well, let's go back to the restaurant. When you look at a menu, you don't just order the most expensive dish, right? You order what you're actually in the mood for. So the question is, how do you order the right CPU meal for your needs? It really just boils down to this simple 3-question menu. First, what kind of meals are you going to be making? Are we talking simple snacks or complex gourmet feasts? Second, what's your budget? How much can you afford to spend on this kitchen? And third, and this one's a crucial technical point, you got to make sure the chef actually fits in the kitchen. The CPU has to be compatible with your computer's motherboard. And here's how that all shakes out in the real world. For everyday use, browsing the web, emails, a small, efficient kitchen is perfect. That's your Intel Core i3 or your AMD Ryzen 3. If you're a gamer, you want that kitchen with those really, really fast chefs. That's where you start looking at a Core i5 or a Ryzen 5. And for the pros doing heavy stuff like 3D modeling or high-res video editing, you need a huge, industrial-sized kitchen with as many chefs as you can get. And that's your Core i7s and i9s or your Ryzen 7s and 9s. So there you have it. We've taken a tour of the computer's kitchen. We've learned that clock speed is how fast the chef works. Cores are how many chefs you have, and threads are how many hands each chef can use at once. But while the CPU is the master brain running the show, it has a partner. A very specialized partner that focuses on just one thing, creating all the amazing visuals you see on your screen. And that leaves us with one final question. If the CPU is the logical brain, the master chef of the kitchen, what do we call the computer's specialized artist? We'll be answering that in our next explainer, when we dive into the graphics processing unit, the GPU. Thanks for joining us, and as always, choose wisely.